Hi, I'm Adolph Oliver, and this video clip here is going to tell us how we can do basic math calculations here using functions. And remember again, the idea is functions are just a nice shorthand that makes it much easier for us to indicate mathematically what we want to do without putting a whole bunch of words. So, the type of things we can do here: addition, subtraction, multiplication, and division. Let's just show you different ways of being able to write these things. Okay, here we go. Somewhere before, folks have defined what f and g was for us, and we'll see that coming up in the examples we're going to work. But then, if they say they want f plus g in parens like this, that means, of course, they want us to add these functions together. And of course, then you look at the guy behind that, and if that's just your variable x, that means you're going to leave the x in those equations. So, f plus g of x is the same as taking f of x and adding to it g of x. And this is often what we break it down to be able to solve the actual problem. Okay, likewise, f minus g of x means I want to take f and subtract g, so it will be the same as taking f of x and subtracting g of x. And again, since we had the x left here, that means we leave the x in the equations. Well, f and g next to each other indicate multiply, so we're going to want to multiply these guys, leave the x. So this is the same as if we took f of x times, this is our old multiplication dot, times g of x. Now, the last thing, of course, division. Division, of course, can be indicated by a fraction. This is f divided by g, and we're keeping the x's in it. So I'm going to have f of x on top in the numerator divided by g of x in the bottom, the denominator. And of course, there is this rule: when we have fractions and do division like this, the guy downstairs cannot equal 0, so we would say g of x is not equal to 0. Okay, well, this is easy to work with. Let's look at some examples so I can convince you of that. Okay, here's our first example. Notice that we've already had h of n and g of n defined for us. Now, we know that these guys are functions because they're set equal to equations over here. So that's how come you know this is not multiply. This is the function h, because here's the rest of the equation, the same with g. Okay, here we are. In this particular problem, we want to find h plus g of n. So we're going to leave the n in the equation. And so the first thing we do is remind ourselves h plus g of n equals h of n plus g of n. Okay, now what we simply do then is plug both of these guys in. In other words, what I'm going to do is substitute in what h of n is and add to it what g of n is. So that's why we say this is just simple substitution. H of n is n squared plus 3. Okay, and let's write it in here, n squared plus 3. And g of n is 4n minus 4. Okay, here we go. Okay, well, now we got to clean this up. Officially, there's a plus in front of this first set of parens. There's definitely one in second here. And so the pluses mean nothing's changing. So the signs are all the way that we see them here. So we got one squared term. It goes first. Remember, right in descending order, n squared. Then there's only one term with the n to the first power, and it's positive, so plus 4n. And then we're down to the plain numbers. Plus 3 minus 4, I think, is negative 1. So there it is. This is h plus g of n equals n squared plus 4n minus 1. Okay, well, no surprise. Subtraction works the same way here. Okay, once again, we are given the two functions. G of n equals this, f of n equals this. You've got to be given these functions or there's no way that you can turn around and find the rest of the problem. But since they've told us these, we're all set to go. So here we go. What we've got now is g minus f of n. Okay, which is going to equal g of n minus f of n. Okay, we're doing subtraction here, so here it is. First guy, subtract the second. Now, once again, let's substitute in what these guys are, but notice now we got a minus in front of this second function here, so here we go. What's the gn equal to? Looks like it's 4n plus 4. Okay, and what's the f of n equal to? Looks like it's 3n minus 4. Okay. So, clean this up. Officially, this first set of parents has a plus in front of it. So, we've got here 4n plus 4. Now, distribute the minus in. Minus 3n. Minus times minus gives you plus, so plus 4. Okay. Now combine together. Like terms, 4n minus 3n gives me 1 positive n. You could put a plus 1 in front if you wanted, or you can just write the n. Folks will assume that you got 1 and it's positive. And then plus 4 and another plus 4 will be plus 8. So there we go in our subtraction example. Okay. Here is a multiplication example, and notice it's written with the multiplication dot in between the g and the h, but that's not really needed. And of course we couldn't do this unless someone told us what g of x was and h of x was, and they're defined up here, so we're all set. So what's really going on here is we've got, and it could be written like this, just g of h next to each other, but you can put the multiplication dot like this if you want. And n of x means we're leaving the x. So what we got here are these two guys multiplying each other. Here we go. X cubed minus 4x squared minus x, okay, times the other guy here, 4x minus 3. Well, okay, this is a trinomial being multiplied by a binomial, and one of the best ways to do this is good old vertical multiplication. So what I'm going to do is I'm going to write this second guy underneath here, 4x minus 3, okay, and I'll emphasize that this is a plus 4, and like this is a plus over here in front of this x cubed. Okay, remember how you do this vertical multiplication. You could also use the box method on this if you wanted. Take the guy in the bottom right, multiply everybody on top, and make your first partial product. So here we go. Negative 3 times negative x plus 3x. Negative 3 times negative 4 is positive 12x squared. And then negative 3 times positive will be negative 3x, let's see, that was squared, right? No, that was cubed, I think. Yeah, okay. Negative 3x cubed. Now let's make sure I got this right. This was x cubed, x squared next to the first power. So negative times negative plus 3x, negative times negative plus 12x squared, negative times positive minus 3x cubed. Okay, looks good. Now, we've done that guy. Move over to the next one. Multiply everybody by plus 4y. And remember to line them up under like terms to make it easier for you. So, for instance, plus 4 times negative, and negative 1 if you want to think of it that way, is negative 4x squared. Well, this is the x squared column. So I'm going to write it right here. Okay. Then I have negative 4 times plus 4 is negative 16. X times x squared to be x cubed, so negative 16x cubed. I line that up right here. And then the last guy out in front, plus times plus is plus 4x times x cubed will give me positive 4x to the fourth. Now, let's double check this. Plus 4x times negative x will be negative 4x squared. Minus 4 times plus 4, negative 16x cubed. Good so far. Plus 4 times plus will be positive 4x to the 4. I think we got it. Okay, now combine the partial products. Got plus 3x. 12 minus 4 is plus 8x squared. Negative 16 and negative 3 looks like negative 19x cubed. And then we had out in front the 4x to the fourth. You could put the plus sign in front if you wanted or leave it off. Okay, so this told us what to do, and we just used a method that we're familiar with. You could have used the box method in this too if you wanted. Okay, let's go down here and see. Must be division coming next. Yeah, I think that's the case. Here we are. Okay, once again, we've got g of n and h of n defined for us. We know their functions because we got, equations on the right side here. And it says find g over h of x. Well, that simply means that we're dividing these guys. So again, here's what it's going to be. G over h, okay, of, and let's see, it's not x, it's n, huh? Okay, n is equal to g of n over h of n. Okay. Well, what's g of n equal to? N minus 3. So that's the upstairs. What's the downstairs here? 3n squared. 3n cubed. And let's get that right. 3n cubed plus 4n squared. Now, got to see if we can reduce this. Okay, so the top, to make a single term out of it, all we can do is put parents around it. Down below here, I can factor out an n squared. So there's a common n squared. When I factor that out, I'll have 3n plus 4. Okay, that's the bottom now. Well, the top and the bottom don't match. N squared doesn't reduce. So we can leave the problem factored like this, or you could leave it back where it was unfactored here, but you had to factor it to see if there was a chance that you could reduce it, because remember, of course, we do have this standing rule for fractions, whether they're basic math or algebra. Final answer in fractions must always be reduced as much as you can. Okay, here's the last couple of examples to look at. The first one up here is an addition problem again, g plus h, but now notice we want to replace the variable with negative 4, so that means we'll be able to come up with a final number as the answer. Well, let's start working on this. First off, we got g plus h, okay, and if we just wrote this out with the variable to begin with, okay, here it is, then I know that what this would be equal to is g of x, okay, plus h of x. Well now, I don't want g of x and h of x. I want g of negative 4 and h of negative 4. So that's the next things to notify here. We're really after this. G of negative 4 plus h of negative 4. Well, we know how to do this. We go back and get the g function. Okay, here it is, and we're going to add to it the h function. Here it is. but we're going to replace now the variable with negative 4. So the g is going to be 4 times, here's the negative 4 that we want to have in it, plus 1. The second guy, h. Okay, there's the x, but I want to have negative 4, so there it is. And then we have negative 5. Okay, well, let's clean this up. Okay, what's it going to equal? Well, 4 times negative 4 is negative 16 plus 1. So this is negative 15. And then here we have negative 4 minus 5. That's negative 9. Plus times minus is minus. So negative 9. Looks like the whole thing equals negative 24. So there it is. This is what g plus h of negative 4 equals negative 24. Okay. Well, one last example to look at here. Okay. Again, we're plugging in a number here, so we'll be able to come up with a numeric answer just like we got in the last problem. F function and the g function are both defined for us, so we can use them here. So remember then, if we first go f over g of x, that reminds us then that what we got here is f of x on top and g of x on the bottom. But of course we want negative 4. So that means that what we got here is f of negative 4 upstairs and g of negative 4 downstairs. Okay, well, what's this going to equal? Well, the f guy is t squared, so I'm going to be putting the minus 4 in place of the variable t. So t squared plus 4. Okay. And the guy downstairs, g, is 4 times t. And for t, we want the negative 4. And then we have, looks like it's plus 5. So there that is. So what do we got as we go down here to the final round on this? Negative 4 squared, negative 4 times negative 4 is positive 16. Plus 4 is 20, so that's the upstairs. The downstairs here, 4 times 4 is 16, but it's negative 16 plus 5. Looks like it's negative 11. Okay, well, 11 doesn't reduce into 20, so we can't reduce it anymore, but the single minus sign, the best place for it, is out in front. So we'd say negative 20 11ths. And that again is what f over g of negative 4 equals negative 20 over 11.